It's been really nice. I wish I would have such a summer school when I was doing my PhD. It's really nice.
Thank you very much. We appreciate it. Okay, so welcome back, everyone. So this is our third company presentation of the evening. Yes, we have Lynn Tran from Autodesk Research. So Lynn, thank you very much for joining us and for giving a presentation. I guess the floor is yours and you can introduce yourself and carry on and as you wish.
Hello, everyone. Can everyone see my slides?
Yes.
Great. Yes, hi, everyone. Really nice to meet you all virtually. I'm Lynn Tran. I'm a senior research scientist from the Autodesk AI Lab. And a little bit about myself, I joined Autodesk around 7 months ago. Before that, I was a PhD at Imperial College London. My research interests are probabilistic modeling and in particular, generative modeling with the focus on 2D and 3D vision. So first of all, a little bit about Autodesk. We are a design company and we help customers to, like the motto say, make anything. So this can range from skyscrapers to smart cars to bridges and blockbusters. So you're seeing on the bottom right the image of the movie The Martian, in which Autodesk was actually involved. And Autodesk's contribution here was to help the principal photography for the space sequences and essentially practicing the shoot before the crew actually set foot on it. So our goal as a company is to automate how things are designed and made. So with that broad range of applications, Autodesk has a broad range of products ranging from the most prominent one, AutoCAD, which is a CAD and drafting software application, to Revit, a building modeling software for architects, civil and mechanical engineers, to Maya, which creates assets for interactive 3D applications. So within Autodesk Research, we have around 200 people in San Francisco, Toronto, New York, and London. Currently, everything is still remote, though. It's been for a while now, so that I have not even seen the office or anyone in person yet. It's been a very interesting and exciting process, though. And within the Autodesk research org, we are split in different research topics, AI, robotics, human-computer interaction and visualization, industry futures, manufacturing, and simulation optimization and systems. So in this presentation, I'm going to focus more on the AI lab, what we're actually doing and what kind of projects we are up to. So in the AI lab, we are currently 17 people, also spread around the world in San Francisco, Toronto, and London. Also a little bit in Germany, as we are now also allowing remote work. And currently we are also a little bit more than 22 people due to the amazing interns that we have. We do cover a big range of research topics within the people in our lab, and broadly, it's split into three main research areas, which is geometry and geometric deep learning, semantics inference reasoning, and simulation and control. And within these research topics, we have been exploring a lot. Some of it I will present to you. I apologize for the brevity of each topic that I'm going to touch due to the time constraints. Yeah, also our team is recently, was just recently formed, so we are still a very young team and still growing. So a big motive in our research is CAD modeling. So the big question around it is, how can we use deep learning and machine learning to help with the creation, modification, and optimization of design? And data is certainly a key part of deep learning, which we have seen with the development of ImageNet and its models. So today, ML researchers have struggled to access large-scale 3D data corpus, and particularly challenging is access to 3D CAD data. So this was like one of the efforts to provide an open source over 8,000 human designed CAD programs from publicly facing customer designs. And this has been recently published at SIGGRAPH. So having the data, now the next question is, how do we model this? Because in 3D, as you all know, representation really matters. And for people in design and for Autodesk, boundary representations are the standard way to describe 3D shapes in CAD applications. So boundary representations combine lightweight parametric curves and surfaces with topological information, which connects the geometric entities to describe manifolds. And we have tried to push the boundaries between CAD learning and deep learning with these works, which were published at CVPR this year. So we were trying to tackle this problem of CAD modeling from different perspectives. BREPnet defines a convolutional kernel with respect to the oriented co-edges in the data structure. And with that learned feature vector, it can give information that it's actually very useful for segmentation tasks. UVNet is a little bit different, which uses a face adjacency graph and represents the faces and the surfaces as a UV grid. And then there's CurveGen, which uses a transformer-based graph generative model to model parametric sketches. So the second broad research topic that we are interested in is representation learning. So how can we learn efficient, generalizable, and robust representations? And again, this includes several works which have been published at ICML and are currently under submission at NeurIPS. And in these works, we are trying to benchmark how robust point cloud architectures are against noise data augmentation. And we found out that they aren't that robust, actually. And with the ICML submission and oral, Saeed has also showed that how we can learn task relevant input features by using structural similarity metrics, which can also be easily applied to point clouds. For myself, my first work at Autodesk involved finding a way to use weak supervision for consistent latent variable models. And we also dived into self-supervised clustering algorithms for categorical and texture-based conditional neuroimplicit representation. Yeah, so then another interesting part is RL and robotics, which we work with focus on, especially with robots and doing reliable assembly tests. And doing it actually in the real world is actually really painfully difficult. So what some of us in the team did was building a simulation that let the user build and simulate adaptive robotic assembly behaviors. And there's also a Python toolkit for inverse kinematics, graph set, collision checking, and using. And I was actually involved in a extended work which involved post-estimation, because in these assembly tasks, it's very important to have millimeter accuracy when it comes to post-estimation. And currently, state-of-the-art post-estimation cannot do that. So we are trying to incorporate self-supervised learning for shapes and 3D features to be more efficient and generalizable to post-estimation tasks. A very nice application of this simulation and this toolkit was Coral Makers, a pro bono consulting project that some of us in the team were involved with. As you know, due to climate change, coral bleaching is happening everywhere in the world. So corals won't die because of coral bleaching, but they are under immense stress, and the rate of mortality increases drastically due to that. So Coral Makers is a Australian company which wants to accelerate the process of restoring coral reefs. And they approached Autodesk to build up this dome-like structure to plant little pieces of live corals so that they can grow. This is a very long process. It takes 3 to 10 years. And in order to automate this process, Autodesk was involved in designing this structure, 3D printing it. And currently they are working on automating the process of planting the live corals into the skeletons, which is a really nice application for this robotics project. So I think I'm almost out of time. So this is also, if you're interested in design, GANs can do it. And we have seen a lot of progress in that. And with that, please reach out if you're interested in working with us, collaborating and interning. I'm also happy to make introductions to colleagues if you're interested in a specific paper or project, and come by the booth.
So thank you, Lynn, for the great talk. I suggest we all thank our speaker very warmly now.
Thank you.
Okay, that was great. So now we're going to take questions from the audience, and let's start. Do we have any questions?
Can you explain what's the RL component of the Coral Maker?
The Coral Maker itself doesn't have RL in it yet, but for the ARIS project, which is the assembly task, there are a lot of reinforcement learning aspects that we can look at. For example, so with assembling tasks, the order is usually fixed, what we take, what we assemble to it. So can we, for example, using causal inference to infer the order and how we put the pieces together? So I think there are exciting routes for that, but it's still a project in progress. So yeah, so there are still a lot to do.
That's great. So since this is more of your area of research, you briefly touched upon GANs and design, and you said GANs can do it. Can you now tell us what GANs cannot do yet that you would like them to do at Autodesk for design?
I think GANs. So I have to say, I myself am someone who uses mostly likelihood-based models because I find them more interpretable, in a sense, more theoretically grounded. But I do think recent advances with images and GANs have shown that they work very well in the image domain. However, I still feel like with respect to 3D and graphs, it's not as much used as in the image domain. So I guess in that way, GANs still have to adapt to learn the geometry, and it's feels like still a big black box that is not understood yet entirely. So I guess that's still yeah, a lot to do.
Okay, thank you. Other questions? All right, well, if there are no other questions from the audience, then I suggest we thank Lynn again for the great talk. So thank you, Lynn, for the presentation. It was very interesting. Autodesk has a booth in our company evening on the town, and I invite everyone to check it out and to talk to Lynn, who will be there, I suppose. So, and Lynn is also participating in the summer school, so you can reach out to her anytime. So thank you and see you soon.
Yeah, please come by. Bye.